He laughed at 50,000. He never expected the schedule. Berlin. A green felt desk. A thin memo. Hermann Göring skims a report and smirks. America claims it will build 50,000 aircraft a year. Let them try. He says, cars aren't bombers. Here's the turn in Detroit. A Danish-born factory master, William S. Knudsen, has already started. He works for $1 a year. He doesn't trade insults. He rewrites calendars. Context matters. In 1939, the United States produced about 3,611 military aircraft. The Army Air Corps flies roughly 1,700 combat-capable planes, many tired by modern standards. No sane planner would promise a 14-fold surge. The president does anyway and does it in public, on Capitol Hill. Franklin Daguerreotypes. Roosevelt puts it on the record the nation must gear up to build at least 50,000 planes per year. Not a slogan, a requirement. Now picture the other side of the ocean shop foreman, with pencils behind their ears. They hear the number and don't laugh. They map jigs, fixtures, sub-assemblies. They hunt second sources for engines and instruments. They stretch lines, then teach lines to change without stopping. This is the real threat Göring missed tempo. A democracy that can argue at noon, award contracts at dusk, and pour concrete by dawn within 4 years. The question isn't whether 50,000 is possible, it's how a coalition of plants from Seattle to Ypsilanti can push toward nearly 100,000 in 1944 while sustaining crews, training pipelines, and spares across 2 oceans. Göring laughed at a number. What defeated him was a schedule and a country that kept it. Sources for segment context, FDR message to Congress. May 16, 1940, U.S. Army Air Forces Statistical Digest. Biographical materials on William S. Knudsen. The job fell to William S. Knudsen, the carman who could turn promises into parts. Presidential advisor Bernard Baruch put it bluntly: if anyone could deliver the impossible schedule. Knudsen was first, second, and third. Knudsen walked away from a $300,000 executive paycheck to serve his adopted country for a token salary, carrying auto industry discipline into aviation jigs and fixtures, traveling sub-assemblies, second source suppliers, and lines that kept moving through design changes. The effect was immediate, within 2 years. U.S. plants were turning out about 2,000 military aircraft per month, roughly a 20-fold jump. Ford announced the vast Willow Run bomber works. Boeing enlarged its Seattle footprint. Douglas hired by the thousands. The arsenal of democracy stirred to life. Willow Run began as cornfields outside Ypsilanti and became ambition cast in steel, the world's largest single-roof plant, about 3.5 million square feet. With a mile-long line, Ford production chief Charles Sorensen vowed a B-24 every hour when others managed one a day. Reality hit hard. The first bomber off the line needed a rebuild. Early quality failures approached 50%, and output stalled near 56 a month. Skeptics sneered. Will it run? Engineers refused to blink. They decomposed the B-24's 488 193 parts into disciplined sub-assemblies, introduced hydraulic riveting, prefabricated wiring looms, and moving final assembly. In 1 year, they absorbed 578 design changes without stopping the river of work. Momentum followed. Monthly totals climbed to 148, then 365 by December. The breakthrough arrived with 428 B-24s in a month, about 1 every 63 minutes. One plant now signaled an industrial tempo Germany could not match. Tunisia gave the first hint. Luftwaffe officers like Johannes Steinhoff of JG-77 noted that U.S. crews were no longer green, and more telling, their numbers grew by the day. The tempo sharpened with the 27 January strike on Wilhelmshaven, the first U.S. raid into Germany proper. By October's Black Thursday over Schweinfurt, losses were brutal. Yet replacement math turned the knife. An American group could lose dozens of B-17s and field new aircraft within weeks. The arithmetic was becoming the story. Then came Big Week, 20 to 25th of February 1944. The 8th and 15th Air Forces launched roughly 300 to 500 heavy bomber sorties against aircraft plants. Sources vary, but the Luftwaffe lost 262 to 355 fighters, and more, damaging about 100 veteran pilots. Adolf Galland warned Berlin that Germany was losing 1,200 fighters per month while building 1,000. The U.S. was producing 2,500 fighters monthly while losing 400. Over Brunswick. Ace Heinz Bear recalled bomber streams from horizon to horizon, 8 interceptors facing hundreds. The odds had shifted from daring to impossible. By 1944, U.S. aircraft output reached a jaw-dropping 96 Tru-70 airframes, about 16 AW-48 4-engine bombers, 35 AWs 743 fighters, and roughly 22 591 multi-engine types. 1 year of American production approached or exceeded Germany's entire wartime total. The gap was qualitative. 2. Typical U.S. Heavy bombers flew with 50 caliber batteries, powered turrets, modern bomb sights, and robust navigation kits. German interceptors increasingly launched with short fuel and partial ammunition loads, and too often with unreliable radios. The factory web behind that peak was the real weapon. Boeing Plant 2. Seattle pushed toward 16 B-17s per day by late spring. Douglas grew from a small pre-war shop to roughly 167,000 workers across multiple sites. North American turned out about 500 P-51s per month. Lockheed drove P-38 cadence to roughly 1 every 90 minutes, while folding in thousands of combat-driven modifications. Upstream. General Motors built 57 658 aircraft engines. Packard produced 55 523 Merlin V-12s. Alcoa multiplied aluminum output several-fold. Dow's magnesium production soared. Pre-war, women were under 1% of U.S. aircraft labor within a few years. They became a majority in several plants, with roughly 310,000 women across the industry. On the Long Beach floor at Douglas, whole crews turned to inspection and instruments. Defect rates, records suggest, fell from about 3.2% to 0.3% as standardized gauges and checklists spread. At Willow Run. Roswell Monroe, the Rosie the Riveter. Many viewers recall could drive 3,000 rivets in a shift with near-perfect accuracy. Manufacturers adapted the shop to the workers' lighter pneumatic tools, better reaches, redesigned fixtures for smaller grips, safer station heights. German intelligence read female employment as desperation. In practice, precision improved especially in wiring, instruments, and inspection proof that inclusive mobilization was a strength, not a weakness. As U.S. output surged, Berlin doubled down on dispersal. At Göring's direction, the fighter emergency drive, often called the Jägerstab, pushed work into tunnels and ad hoc sites. At Mittelwerk, about 60,000 prisoners labored in horrific conditions. Tens of thousands died. Underground shops yielded more defects than aircraft. Sabotage rose, and shuttling parts between scattered sites bred delays. Quality control sagged so far that the complex turned out fewer engines per month than a single Ford plant in Chicago. Across the ocean, American innovation accelerated. B-29 production went modular, spread over 4 major facilities with interchangeable sections, pressurization, remote turrets, and long-range navigation moved from drawing boards to line fixtures. Late-war unit costs landed in the hundreds of thousands of 1940s dollars, and monthly output approached 100 airframes by early 1945. Germany's answer in technology was real, the Me-262. It was roughly 100 mep, 160 km per h, faster than top Allied piston fighters and deadly in a pass. But the Jumo 04 engines demanded overhauls after only tens of hours. Spares were thin, fuel quality erratic, and training pipelines strained. Roughly 430 were built. Rarely did more than a couple of hundred sit operational at once. Meanwhile, the U.S. could pursue jets and pistons in parallel. The Bell P-59 proved a cul-de-sac, but Lockheed's P-80 reached limited service before war's end. The contrast defined the production war German innovation without reliable throughput versus Allied scale, standardization, and logistics in total war. Quality without quantity is a promise the battlefield cannot keep. The turning point was visible from the beaches on invasion day. Allied planners could call on about 11 590 aircraft against roughly 319 German sorties, a margin near 36-1. That ratio wasn't a lucky hour. It was the tip of an industrial spear. In the 5 months before the landings, preparatory strikes dropped roughly 145,000 tons on transport nodes. Airfields and factories more tonnage than Germany dropped on Britain across the entire war. Transport fleets then moved 3 airborne divisions in a single day, using more lift than Germany ever assembled in its transport arm by the winter that followed. A routine major mission could see 1-200 heavy bombers escorted by 900 fighters. Long-range P-51. Mustangs with drop tanks and disciplined radios could range deep to Poland, keep formation, and still fight on station. German pilots reported facing streams that seemed to fill the horizon, the escorts arriving in numbers that made interception feel less like a duel and more like swimming against a current. As the tide turned, senior figures in Berlin stopped speaking in absolutes. Diaries and staff conferences from late 1944 show a new, reluctant theme: the enemy's factories and fuel, not just his tactics, were determining the air war. Field commanders warned that the Americans could accept losses and still return stronger. Air leaders conceded that training pipelines and fuel shortages, not just airframes, were grinding down readiness. Later testimony by armaments officials would argue that systematic attacks on industrial targets reduced output across tanks, aircraft, and motor transport by significant margins. For Hermann Göring, the reckoning became personal after capture. Detained first in Augsburg and then at Camp Ashkan in Luxembourg, he faced interviewers and statistics. Records of those sessions suggest a shift in tone. He had expected American potential to be great, he said, but had not imagined the execution the way one plant like Willow Run could act as a multiplier for an entire system. The logistics impressed him most, sustaining armies across 5,000 miles while maintaining production at home. We struggled to support forces 500 miles from Germany. He admitted in substance, the Americans supplied forces across oceans. At Nuremberg, prosecutors laid the graphs beside the films. Monthly American aircraft output by 1944 surpassed what Germany managed in many full years. Jurists watched assembly lines spool across screens while a clerk read totals: airframes, engines, escorts, transports. A prison psychologist later noted Göring's fixation on ratios, his habit of comparing a single American factory to Germany's sectoral totals. When confronted with engine counts, hundreds of thousands produced in the United States versus far fewer in the Reich, he reportedly fell quiet, whatever one thinks of strategy or courage. The mathematics of defeat were no longer abstract. They were columns on a board, numbers that had overwhelmed the sky. I like to picture the floor after the whistle chalk marks on a planning board, torque charts curling at the edges, a last crate sealed with a stencil that simply reads, "Accepted." The scale still startles. from a pre-war baseline of a few thousand military aircraft a year. The United States finishes the conflict with roughly 295 9D-59 accepted on the order of 97,000 bombers, 99,000 fighters, and nearly 100,000 trainers, transports, patrol planes, and other types. Rounded numbers. Yes, but they capture the essential truth. It wasn't just quantity. It was systemic superiority tooling, training, logistics, and a culture that learned fast, at peak. About 2 million Americans work somewhere in the aircraft ecosystem: inline assembly, engine plants, instruments, aluminum and magnesium, machine tools, transport, depot maintenance, and training. The faces are broad and ordinary women new to heavy industry, black and white workers at adjacent benches, Mexican-American riveters, Native American inspectors, disabled veterans on the gauges, teenagers on materials handling, older machinists retrained to jigs and fixtures. Nazi intelligence had read this inclusion as desperation. On the shop floor, it became precision. Repetitive tasks favored standardized grips and gauges. Inspection crews drove defect rates down with checklists, wiring, instruments, and sub-assemblies turned into disciplines as much as parts. What those crews built altered manufacturing itself. The statistical quality control techniques refined for bomber lines spread into civilian factories after the war. Change-tolerant flow lines that could absorb engineering updates without stopping migrated from Willow Run and Seattle into post-war auto, appliances, and electronics. Tooling specialists who cut their teeth timing a mile-long line later designed the flow for rockets and jets. The people who managed parts lists in the tens of thousands wrote the habits that would become aerospace configuration control. The money story confounded early skeptics. Aircraft and related programs consumed tens of billions of 1940s dollars, with the B-29 alone running into the billions, yet the result was not bankruptcy, but a full employment economy. Unemployment collapsed. Household incomes rose. Savings accumulated in war bonds purchased at the very plants those bonds financed. The paradox is only apparent in a mobilization this broad. The new capacity is not a sunk cost. It becomes the scaffold for peace. After VJ Day, aluminum smelters that fed wing spars pivot to suburban housing, chemical plants optimized for aviation fuel flow into plastics and synthetics. The machine tool base that cut bomber ribs retools national industry. The war's waste becomes the next decade's infrastructure. Behind the shiny planes sat ordinary but decisive systems. The War Production Board orchestrated an archipelago of 184,000 companies into coherent schedules and priorities. IBM punch card machines tracked parts counts and routing sheets at a scale no paper ledger could bear. The MIT Radiation Laboratory and allied labs translated operational needs, navigation, radar, bombing through cloud into black boxes that line crews could install and maintain. And the feedback loop shrank to combat time. A pilot's debrief on a Monday could become an engineering change on a Thursday and a line fixture the week after. Consider just one famous tweak when frontal attacks started slicing into B-17s. Chin turrets began appearing on production fortresses in weeks, not years. When Pacific crews needed range, producers folded ferry tanks and block changes into the flow with minimal disruption. By contrast, dispersed German plants, whipsawed by transport gaps and air raids, struggled to push modifications across a workforce held at gunpoint. If you want the difference in one word, try adaptability. The American system produced more airframes, yes, but it also produced more learning per month, shorter loops from field to drawing board to fixture. That learning compounded crews trained faster with standardized trainers. Spares arrived in predictable crates. Depot maintenance worked from common parts lists. and tactical doctrine could assume the kit would match the manual. In Berlin, officials could write bold targets for jet squadrons, but fuel, engines, and qualified pilots would not arrive on the same week. In the United States, procurement, training, and logistics rode the same calendar. Post-war interrogations capture how this felt to leaders who had dismissed it after his capture and transfer to Allied custody. Hermann Göring faced charts and film of what he had mocked. Accounts of those sessions suggest he conceded the point that matters to historians. He expected American potential to be large. He had not expected execution at that tempo. One American plant, Willow Run, came to symbolize for him an adversary that could fix problems while increasing output. He reportedly marveled at the oceanic logistics supporting armies 5,000 miles away, while sustaining the home front compared with the Reich's difficulties supplying forces a few hundred miles from the Ruhr. At Nuremberg, those ratios turned from abstractions to exhibits. Monthly production bars rising past yearly Reich totals, engine counts measured in hundreds of thousands, reels of final assembly sequences that looked less like inspiration and more like administration, the quiet hero of modern war. Military historians have argued for decades about air power's exact weight in victory, but a broad consensus holds without the material base that production delivered. There is no sustained daylight offensive over Germany, no air cover of that density for Normandy, no global training pipeline to replace losses with seasoned crews, as Richard Overy frames it. Wars of this scale are decided by the weight of material and by the systems that keep it flowing. The crucial term is not inevitable, but organized democracies can, when sufficiently threatened and sufficiently led, align policy, industry, and society into a machine that outlearns and outlasts. None of this is triumphalism about bloodshed. It is a hard lesson about institutions and calendars. The Allied achievement demonstrated that free workers, with voice and mobility and a stake in the outcome, could outproduce coerced labor in every meaningful metric: throughput, quality, and innovation. It is also a cautionary note for any strategist who reads only the first half of an adversary's balance sheet. In 1940, America looked unready. By 1944, it was an industrial colossus. That turn wasn't magic. It was contracts, tooling, training, and feedback, all measurable, all improvable, all dependent on trust between government, firms, and citizens. Göring's journey from laughter at a 50,000 plane line to the courtroom where production charts outgrew his Air Force traces a larger fate. A regime that prized ideology over engineering, command poses over supply discipline, and wonder weapons over maintainable fleets was beaten not only in the air, but in the ledger. If there is a single photograph that sums the legacy, it isn't a formation shot over Berlin. It's a worker with a micrometer and a rubber stamp, initials crisp beside a lot number, sending a part forward on time for our audience planners, veterans, citizens. The conclusion is sober and usable. Production lines can be as decisive as front lines, assembly workers as crucial as pilots, calendars as lethal as cannons. When a free society aligns its arguments with its schedules, it turns potential into tempo, and tempo wins campaigns long before a map changes color. Selected sources for this segment: transparent and non-exhaustive U.S. Army Air Force's Statistical Digest, WL2, Annual Aircraft Acceptance Totals and Categories, Workforce and Output Trends, National W2 Museum New Orleans Overview of U.S. Aircraft Production, Willow Run and Homefront Mobilization Essays, the Henry Ford, Benson Ford Research Center, Willow Run Process Materials and Shop Floor Accounts, Richard Overy, Why the Allies Won Industry, Logistics, and the Weight of Material Interpretive, Atom 2s, The Wages of Destruction, German War Economy, Dispersal, Fuel, and Labor Constraints, GM. Gilbert, Nuremberg Diary, 1947. Observations on defendants' post-war reflections use cautiously. Compare with trial records, Smithsonian National Air and Space Museum, Boeing Historical Summaries, B-29 Systems, Modular Production, and Post-War Technology Diffusion.